Hi guys, a warm welcome to all of you to my channel. In today's video, I'm going to cover the concept of multiplicative cipher. I'll explain you the encryption and decryption that is done using multiplicative cipher along with one numerical. So what is multiplicative cipher? So a multiplicative cipher is basically an encryption algorithm. Now what does an encryption algorithm do? It converts the secret message, which is called as plain text, into a meaningless message, which is called as ciphertext. Now the ciphertext is such a kind of message which when transmitted over the communication channel cannot be read by anyone other than the authorized user who has the correct key to decrypt the received ciphertext. So multiplicative cipher is a type of encryption algorithm used to convert plain text into ciphertext, and at the receiver end it uses the corresponding decryption algorithm to convert the ciphertext into plain text. Now let us see this with the help of a block diagram. So the input, which is a secret message which has to be transmitted by a sender, is given to encryption algorithm. The secret message is also known as plain text. The plain text is given to an encryption algorithm here, which is a multiplicative cipher encryption algorithm. Now the encryption algorithm always uses two inputs. One is the plain text which has to be transmitted. Other is the secret key which is known only to the authorized sender. So he uses this key K and the input plain text and encrypts the message and generates the output, that is the ciphertext, using the formula C is equal to P multiplied by K mod 26. Now why does the multiplicative cipher use mod 26 here? Because a multiplicative cipher works on a finite field of 26 numbers. Assuming that the plain text is made up of letters from A to Z, if you count the letters A, B, C, D till Z, you will see that it is made up of total 26 numbers. So since the algorithm processes numbers, the letter of the plain text are mapped to numbers. For example, A is mapped to 0, B is mapped to 1, C is mapped to 2, and so on and so forth. Z is mapped to 25. So if you see the numbers given for A to Z, it is ranging from 0 to 25. That is total 26 numbers. So since multiplicative ciphers play around with these 26 numbers, that is from 0 to 25, it works on mod 26 domain, and hence in the formula you will see mod 26 here. Now coming back to this block diagram, the ciphertext, which is a meaningless message, is now transmitted through the public communication channel to the other end, that is the receiver. The receiver receives the ciphertext C and uses a decryption algorithm and generates the plain text P. Now in order to decrypt the data, he also requires the key K, and this K has to be the same K as that is used by the sender. So the sender and the receiver have to share the same key, which has to be secret, because if by chance this key is hacked by an attacker or found out by an attacker, he can use the decryption algorithm and read your plain text. Therefore, to protect your messages from being read by the attackers, you have to keep the key safe and secret, which is the primary requirement of multiplicative cipher algorithm. Let us now see the formula for decryption. The decryption algorithm is an algorithm which takes the ciphertext as the input and generates plain text as the output. Therefore, it generates P using the formula C into K inverse mod 26. Now, what is K inverse? K inverse is called as modular multiplicative inverse of the key K. So, with this, let us quickly revise on to the formulas of multiplicative cipher. Multiplicative cipher encryption algorithm generates ciphertext using the multiplication of plain text and the key mod 26, while the decryption algorithm generates the plain text using the ciphertext multiplied by modular multiplicative inverse of K mod 26. So these are the two formulas which we will be now using to solve the numericals. Let us now solve this numerical. The given numerical is encrypt the plain text secret using key 5. So in order to encrypt the plain text, the encryption formula generates ciphertext using P into K mod 26. Okay. Now what is K? K is 5. What is P? P is given as S S-E-C-R-E-T, secret. It is letters. Whereas formula that is used for computation is multiplication of numbers. So we have to convert these letters into numbers. So the first step of the algorithm is to map the letters to numbers. That is, first write down A to Z and then assign numbers to each of them. A is assigned to 0, B is assigned to 1, C is assigned to 2, D is assigned to 3, 4, 5, 6 and so on and so forth till Z is assigned to 25. So with this mapping table, now you can take the plain text letter S-E-C-R-E-T and assign the corresponding numbers to it. For example, S is mapped to 18, E is mapped to 4, C is mapped to 2, R is mapped to 17, E is mapped again to 4 and T is mapped to 19. So these are my plain text numbers, that is 18, 4, 2, 17, 4 and 19, which will be processed by the encryption algorithm, that is P into K mod 26. So the second step is you make a 3-column table with the first column for plain text. The plain text that is given to us is S-E-C-R-E-T. So write down the corresponding numbers of each of them. So S from the mapping table. So S is mapped to 18, E is mapped to 4, C is mapped to 2, R is mapped to 17, E has got its corresponding number as 4 and T has its corresponding number as 19. Now these numbers are processed by the multiplication cipher encryption algorithm. Now let us see how it does it. So multiplicative cipher encryption algorithm multiplies the plain text and the key using mod 26 arithmetic. What is the key that is given to us? Key is 5. So let us begin with the computation. First plain text number is 18. It multiplies it with 5. We get 90 mod 26. Modular arithmetic, I've covered it in detail in my previous video, whose link is given in the description box. I will request everyone to see that video so that the computation of modular arithmetic is very clear and everyone can do it easily. However, I shall explain it here in short. A mod B is always equal to the remainder that you get after doing A divided by B. Therefore, if I want 90 mod 26, I should divide 90 with 26. So 26 into 3, we get 78. And the remainder is 12 and therefore my answer here is 12. So my ciphertext number that I get is 12. Let us check out the letter E. The number corresponding to E is 4. So we do 4 into 5, that is 20 mod 26. Now here 20 is a number which is already in the range of 0 to 25. Therefore the final answer here remains 20. So my ciphertext letter is 20. So the next ciphertext letter is C and the corresponding number for C is 2. So we have to encrypt the number 2. So we take 2 multiplied by 5, it is 10 mod 26. So as you see here, 10 is a number which is within the range of 0 to 25. Therefore 10 mod 26 remains as 10. So my ciphertext number here is 10. The next letter which you have to encrypt is R, which has corresponding number 17. So we have to encrypt the number 17. So we take 17 multiplied by 5. When we do this, we get 85. Now if you see this, 85 is a number which is greater than 26. Therefore you have to perform modular arithmetic. How do you do that? As I told you, A mod B is basically a number C, where C is the remainder of A divided by B. So you have to take the number 85 and divide it by 26. So 26 into 3 is 78 and the remainder of this is 7. Therefore 85 mod 26 is 7. So you got the ciphertext letter 7. Moving ahead with the next letter E, which has a corresponding number 4. So we have to encrypt number 4. So we multiply 4 with 5. 4 into 5 is 20 mod 26. So again if you check, 20 is less than 26, therefore 20 mod 26 is 20. The moment your A is lesser than B, A mod B remains A. So the next letter that you want to encrypt is 19. So you do 19 into 5, which turns out to be 95 mod 26. So 95 is a number which is greater than 26. Therefore you have to do modular arithmetic. You take 95 and divide it by 26. So 26 into 3 is 78 and the remainder here is 17. So 95 mod 26 is 17. So your ciphertext letter is 17. So you have got your ciphertext numbers for these plain text numbers. Now the next step is to map these numbers to its corresponding letters, for which we make use of this mapping table given below. So from this mapping table, it is seen that number 12 corresponds to letter M. Number 20 corresponds to letter U. Number 10 corresponds to letter K. Number 7 corresponds to letter H. Number 20 corresponds to U and 17 corresponds to R. Therefore, these are the final ciphertext letters for a plain text secret. That is a final answer. The ciphertext that we got for plain text secret using key 5 is MUKHUR.